Lesson 66, simplification of radical expressions and square roots of large numbers. Okay, we basically did this, we're just kind of combining it. So remember last week we learned you could add radicals or square roots that have the same number underneath the house, right? And we also learned how to simplify them. So we're going to do both today. So write down square root of 18 plus the square root of 8. All right, 18 breaks down how? What's probably the best way to do 18? Yeah, 9 times 2 is better than 6 times 3. Because what is the square root of 9? 3. All right, so a 3 comes out because we take the square root of 9, and the 2 stays inside. All right, and then how would we break down 8, everyone? It is 4 times 2. And then what's the square root of 4? 2. So that comes out front, the square root of 4, and then this 2 stays inside. Now that we simplified, we can add them together because they both have a root 2. You add the numbers in front. So 3 plus 2 is 5, and we keep it as a root 2. The radical does not change, okay? All right, let's try another one. 2 root 18 minus the square root of 27. So we just did 18 on the last one. So again, it's best to break it down as 9 times 2. And then what's the square root of 9? Okay, this one already has a number out front. I don't know if we've done one like this, okay? So I pulled out a 3, and it is going to multiply to whatever is already out front, okay? So anytime you take that square root out, multiply it to the number in front. So this gives me 6 root 2. All right, and 27 is what times what? 9 times 3. All right, and what is the square root of 9? So this would be minus 3 root 3. All right, the square root of 9 becomes the 3 in the front, and the other 3 stays inside the house. And by the way, do those subtract? No. All right, they have different radicals, so you just leave it like that. All right, let's try another one. Okay, here we go. So 27 we just did is 9 times 3. And we take the square root of 9, which is 3. And the other 3 stays inside the house. And then 18 is 9 times 2. And the square root of 9 is 3, which is going to multiply to this 3 that's already in the front. So minus 3, and the root 2 stays in the house. Now I have this 45. What's a good way to break down 45? 9 times 5 would be a good way because 9 is a perfect square number. Again, you're looking for perfect squares. That's why I'm picking the ones that have 9s in them or 4s in them, okay? And so the 9 we take the square root of, which is 3. And that 3 is going to multiply to this 6 that is already here. So that's an 18. And then the root 5, he stays inside the house. Do any of those add or subtract? Well, that's a no, because we have a root 3, a root 2, and a root 5. All right, so they stay separate. All right, let's do these. Big numbers with lots of zeros. What number multiplies together to give you a bunch of zeros? Tens, okay? You always want to think tens. So we break this down fully. Like I just do it right off the bat. So I'm going to write 5 times, and the number of zeros that you have is the number of tens that you need. How many zeros are there? So I'm going to write down times 10, 2, 3, 4, 5, 6, 7. Right? If I multiplied that, I would get that lovely 50 million. All right? So then we're looking for perfect squares, which is any pair, right? So I'm going to take this pair of tens. This is really the square root of 100. And what is the square root of 100? 10. So anytime, remember, you have a date, they leave the house as 1, right? So I have these 2 tens. They leave the house as 1. And then I have these 2 tens. They leave the house as 1. And these 2 tens, they leave the house as 1. How many tens are on the outside of my radical? 3. Okay, so I have 1, 2, 3. This is the square root of 100 is 10. The square root of 100 is 10. The square root of 100 is 10. All right? I can go further, though.
because I still have 50 left under the house, right? I have 5 and I have 10. What's neat about this is I can break down this 10 to 5 times 2. So what other number has a date? 5. I now have 2 5s. They leave the house as 1. And the sad little 2, who does not have a date, stays inside the house. All right? Everybody on the outside multiplies together. 10 times 10 times 10 times 5. So that would be a 5 with 3 zeros. 5,000. Whoops, I meant to put a 2 when I wrote a 5. Root 2. All right, 5,000 root 2. Okay, let's try another one. Okay, how many zeros are there? 5. So I'm going to break it down as 5 times, and I want 5 tens. Okay. All right, so I have a date and a date. All right, they leave the house as 1. So I'm going to write 2 tens on the outside. This one also breaks down further, just like the last one. So I can separate this 10 out to 5 times 2. What else gets to leave the house? Yeah, we've got a date here, so a 5 leaves the house, and the root 2 stays inside. All right, so multiply those numbers on the outside. That would be 500 root 2 for my final answer. All right, let's do one more. 700 million, the square root of 700 million. All right, how many zeros are there? 8. 1, 2, 3, 4, 5, 6, 7, 8. How many tens are going to leave the house? 4. Yes, all of them, but each pair leaves as 1. So we're going to write down 4 of these on the outside. All right, and the 7 is the one who's all alone, and he stays in the house. Then multiply those tens together. That would be a 1 with 4 zeros. So I get 10,000 root 7. Okay, everybody feel good about that? Pretty easy. Just make tens and take out the pairs. All right, guys, let's try some whiteboard.